Question for this week is, what determines emission intensity?
As a reminder, emission spectra graphs wavelength in nanometers against intensity. The intensity is what we will be looking at this week.
Emission intensity is proportional to the number of photons emitted at a given wavelength. It can be used to determine characteristics of most and least common emissions.
In an emission spectra, the peaks and the dips between them tell us a lot about the substance. In our data, one thing we notice is that the peak for green is higher than the peak for red. To understand this, we looked at the absorption spectra.
We noticed that the red dye absorbed almost exclusively high-energy photons, whereas the green dye absorbed about 2/3 low-energy photons and 1/3 high-energy photons.
This means that green most often absorbed lower energy photons. This data makes sense, as we know that colors and dyes do not absorb the color they emit. This is why there is no peak at 620 nanometers for red or at 510 nanometers for green. The reaction that occurred involved equal amounts of dye and activator being mixed together. The energy produced by that reaction was equal for both dyes and caused them to fluoresce.
If equal amounts of energy are put in, but intensity changes, that means that some things other than energy input affect intensity.
We have a theory. It works like resource allocation. If two people have equal amounts of money, but one, Rose, spends more money on the object she buys the most often than Gina does on the object she buys most often, Rose will have less objects than Gina and will run out of money faster.
In terms of glow sticks, both were given equal amounts of energy, but red for the most part absorbed higher amount of energy per photon, so the intensity is lower than that of green, which is like Gina, who absorbed lower energy most often. This also explained the visible fact that the red glow stick did not last as long as the green one.
This difference in absorption and emission intensity occurred because of the different structures of red and green dye. One characteristic that may cause this is that the red dye contains more single bonds than the green dye. Single bonds are longer and only contain one electron pair. This means the electron energy levels around a single bond are further apart, and electrons need more energy to be excited. Conversely, green dye has less single bonds, but also has triple bonds. This may account for the fact that green has a wider range of wavelengths that it absorbs.
In conclusion, emission intensity is caused by the light or energy the molecule absorbs. If the types and amount of energy needed is available, then the energy absorbed will be determined by molecular structure. If not enough energy is produced, intensity will decrease, which was seen as the energy from the glow stick was used up and it dimmed over time.